Welcome to the Programming Electronics Academy podcast. Join us every other week as we explore how everyday people are creating extraordinary things in the world. Find us online at programmingelectronics.com.
Hello, I hope you're doing fantastic, and thank you so much for taking time out of your day to listen to the show. This is Michael with Programming Electronics Academy, and today's guest is pretty awesome. His name is Ted Kinsman, and he is a professor of photographic technology at the Rochester Institute of Technology. He's a very prolific creator of interesting things. He's got stuff published all over the place, probably most namely, he's got a lot of his photography has been featured on all types of television shows and movies. It's a lot of interesting time-lapse stuff. And we'll hear about that in our conversation today, but he's also worked on other like high-speed photography and some interesting printers. So we're going to learn about all of that. So without further ado, let's go ahead and jump into this week's talk. Well, hello, Ted. Thank you so much for joining me for this call. I really appreciate your time.
Well, thanks for having me.
I've been looking into some of the stuff you're up to, and you're up to a lot of interesting things. And in my mind, your work is like famous. It's been on all types of cool stuff. But I'm wondering back to a time when you were kind of just getting started in these different fields, kind of like what your path was to where you are now. What got you interested in, for example, the photography, and where did you get the electronics skills to kind of do some of the stuff you're up to now?
Let's see. I started out always interested in photography. I think it's a lot of times it's what you're interested in as a kid that moves forward. And in this case, I've always had a camera with me and carrying a camera, and there's a lot of photographers out there. So I started around 1991 or so. I started thinking about what types of photography were kind of difficult to do, and there wasn't much competition there. So I started thinking a lot about time-lapse photography and realized that there had really been a great time-lapse photographer in a long time. So I settled into doing time-lapse plants and building all my own control systems to control lights and cameras and all that stuff while I was working. I was a science teacher at the time. I guess I still am a science teacher. And I was teaching middle school and high school students, and I always had 4 or 5 or 6 time-lapse cameras running in the basement, taking pictures of this or that blooming, and eventually, you get a shot, and it would be really cool. You had to shoot film in those days, so there really wasn't a lot of people doing that, not like today. So that idea of controlling a camera with electronics has really run strong throughout my life, and I think anytime you can have a electronics control a camera, you've not only eliminated a lot of competition, but you can take photography into some really unique directions. So that's pretty much what I continue to do today.
So I can imagine that the electronics you were using then have changed a bit to how you're doing it now.
Oh my gosh, yeah. Everything had to be TTL logic and signal. If you wanted to count something, you had to have a pulse generator and count a number of pulses and solder up an array and or solder up like a cascade of counters and change bits, and it's just phenomenally difficult. Even to build a time-lapse controller that would turn a camera on every minute or every 30 seconds was a real pain. So I was a big fan. I had a Tandy laptop computer. For Radio Shack actually made laptops back in the day, and I had a real cheap one of those with a serial port, and I could have a program control the camera, control the stepping motor, and also do lights and things like that with that serial interface. So that was kind of a cool introduction to all the electronics. And once you pick up something like the Arduinos, which I'm told I pronounced wrong because one of my colleagues is Italian and will take every opportunity to correct me. But it's so much easier to get something done or to build something. It's really quite phenomenal.
Yeah, and I've seen some of these high-speed photos that, for example, on Make, I see that there's a lot of stuff that you've published there.
Oh yeah, I try to. That's a great avenue for kind of getting the word out. I built a lot of really wacky projects, and I've put stuff into like journals, which are refereed journals, but it takes about a year and a half to get it refereed, and then they publish it, and then they're like, oh well, why didn't you reference this guy that just wrote this article 6 months ago? And I'm like, well, this is really timely stuff. Someone's going to write the article. So I've given up on reference journals and just throw it into Make or Petapixel or maybe a few other websites too.
Oh, that's really interesting. So on with these high speed photography, are you using an Arduino to set that shot up, or is that a different type of electronics that's handling that?
You could pretty much handle everything with the Arduino, with like the double water droplet system. I have it set up. That code that I published used all delays, which isn't, it's really not, it's not a high level of programming when you use delays.
Yeah, absolutely. So how does you mentioned the water drop system. How does it work exactly?
You have a reed switch, which the reed switches are surprisingly accurate. They're actually very good to the tune of a fraction of a thousandth of a second. I would say they're probably good to less than 1/10,000th of a second in accuracy, which is really surprising for a switch. But they're cheap. They work really well, and they give off a chirp when you run them. So the students always get a little bit of audio feedback if they've got that circuit engaged right. They'll give off a little chirp. And I have that hooked up to a solenoid, and a solenoid is designed to run on 12 volts, but it actually will respond quite nicely at 9 volts. So I have the students run it with a little battery, a 9-volt transistor battery, and that makes drips pretty consistently. And you can actually get the timing well enough for the double water splash to work, which is it's a nice project, and you get the high speed, and you tune a flash down to a 1/64th power. So it's really in the high speed region, and you can get the shots. And there's a little bit of variation. But,
and these shots are great. So it's just to describe it to those listening. It's like you see that water coming down, and then the ripples and it just going up. It's amazing too. I don't know, the architecture of that splash, when you look at it closely, how interesting that is. I had no idea that a single water dropping had so much, complexity to its, how it's dispersing, I suppose. I mean, it's fantastic.
This is actually 2 droplets. The first droplet hits the water surface and bounces up. And just at the very top of its bounce, a second water droplet collides with it. And so they're splattering in kind of space, which is a really cool thing. It turns out that a friend of mine, Martin Waugh, was the first person to see this and to build a machine just to do it. So it's really a testament to his observation that it's sort of caught on and become sort of its own little art form on the internet. But it is pretty spectacular. And there's a whole group of people changing viscosities and changing temperature and changing liquids to get different kinds of splash patterns or bubbles. And the shots that I published aren't really greatly lit. It's pretty much just a nice little how to do it article. But the art form turns on when you have to light those patterns and make beautiful lighting to capture the double water driplets, which is a whole nother story.
Yeah, and I imagine this, aside from the aesthetic appeal of the photos, I would think that these captured instances of time into these, physical processes, I feel like they could inform us about some nature of the experiment, I guess. I don't know.
Well, it's I look at them as a great way of doing science and getting students interested in science, which is really one of my big goals. And I think that these beautiful science shots, they do draw people in, or at least I hope they do. They want to know how they're doing. They realize that programming or running a camera like that is something that's not out of the reach. And matter of fact, it's easier to do now than any other time in history, really.
Yeah, absolutely. So I want to move on to another project that I'm just fascinated with, and it's the machine that prints photos with drops of coffee.
Yeah, okay.
So I don't know if you could, I guess that's a pretty straightforward title, but it's just off the wall. I mean, it's it's and these images are fantastic. So
They're
if you
goofy,
would,
yeah.
they are. If you wouldn't mind, kind of just talking a little bit about the inspiration for this project, maybe just quickly tell us what it is and why
Uh,
you went and built it.
I was doing a project for one of the TV shows that needed splash patterns of blood. I think it was one of the CSI shows, but it might have been one of the other. I don't know. There's so many of them, but they wanted all these different drops photographed with high speed, and they wanted the like fake blood, which in this case was just red water, dripped from different heights. And as I dripped it from different heights, I realized that it made a different size splash patterns, which I'd known, but it was really kind of nice to see it all on sheets of paper, all calibrated with different heights and stuff. So I thought, well, that would be really cool to make a machine that changed the height of the drip to make a pixel bigger or smaller. And so I built this. Actually, at that point, I just got rail and all the pieces to bolt together using 8020 prototype rail. And I threw it on my back porch, and it sat there for about 3 years. And eventually, in August of 2014, I decided I was working for an art school, and I had about a week and a half to kill. And I said, oh, I should just bolt that thing together and get it up and running. And after I put it together and started doing some test patterns, I realized that the drop sizes did change, and they do have a pixel value. In the case of the blacker, the bigger the drip, and there's a contact angle and wetting angle, and there's a whole bunch of physics involved with putting ink on paper that I didn't really spend a lot of time thinking about in the past. But now it's like, holy cow, there's a lot of physics there that I kind of passed over in my physics experience. But I put together a system and tried it out, and my brother, who's a retired computer programmer from Kodak, he looks at the code and he goes, what the hell are you doing? And pretty much sharpens it and makes it about 10,000 times faster and better. That happens after 30 years of being a programmer, I guess. And he helped it really take it to the next level to really perform some nice patterns. And it's really quite a remarkable process because your eye is really tuned to pick up human faces and not much else. So we can actually recognize a person with probably less than 100 pixels. And I think Google did a test where they said that it only took 12, but I'm not sure on that. But these have about 8,000 pixels on them, and you can really recognize a face very easily. But not a lot of other things, like a picture of a house might be pretty tricky to recognize, or other kinds of things. So you can recognize cats and things like that, not too bad. But your brain really fills in a lot of the detail and makes it a lot better. So that's kind of an interesting process, and the patterns really do work best with faces. So surprisingly, I use the same solenoid for the coffee printer as I do for the double water drip system. So the double water driplet system actually had a little bit of say in the coffee machine.
Nice. So does the size, so if I understand correctly, the size of the drop then determines the darkness of that pixel?
Yes.
Somewhat? Okay.
Yeah, and there's I think in most of them I use 256 different levels, but in reality the drips don't really perform like that. So I think they have about maybe 30 or 40 different size drips in the end. The drip also has what's called a contact angle on a surface, whether it wets the surface or doesn't wet the surface. And you can actually build a very complicated algorithm to take that into consideration to try to change the drip size. And after I did that, I spent a couple of days changing the drip size using this contact angle and everything. It made absolutely no difference whatsoever. So I chopped all that line out of there. And you just, simple, keep it simple. Don't make it more difficult than it needs to be.
And so when the drop hits the paper, it stays like a drop. I mean, it's still like a circle, like a bead. It's pretty neat.
Yeah, and then it eventually, as it starts to wet the paper, it wicks out. And each paper is different, so you have to do a calibration for each paper, which is a real pain.
So does the photograph live on then after it soaks in, or does it
Oh yeah, yeah, it'll be permanent.
Okay.
Oh,
All
well,
right.
as permanent as a coffee stain is.
Pretty
That's
permanent on all my white clothes. So, I mean,
yeah, that's a big question. Does it last 20 years? Does it last 50? I don't think it lasts that long. But
that's
it's probably a little bit better than newsprint, but not much.
that's awesome.
But yeah, I was very surprised that it kind of went viral. It I took it up to the Make Show in Toronto, and people loved it. And actually got I was very proud. They printed out a 3D best of show uh, print. They did um, a 3D print best of show made out of plastic with one of the 3D printer extruders things, and they gave it to me. I don't get a lot of awards these days. They don't give a lot of those out in photography. They give you a book or a free print or something like that, but they don't actually give you a physical object. So that was the first time anyone's ever given me uh, a nice little 3D printed best of show award, which was kind of fun. But the whole coffee printer just kind of sat around, and I said, "Oh, I got to write that up for Make," and I finally wrote it up for Make, and they liked it, and then it caught. Petapixel picked it up, and I think Petapixel really took it to the next level because their viewership was so huge. And probably the other thing is, since I was just giving away the code and how to build one and stuff, people didn't really think I was out to gouge people on some sort of big art project. Come buy this for $1,000. So they were very interested to share it. And I think I've sold a couple pictures to cover paper costs, but for the most part, it's has not made any money at all. It's one of those entertaining kind of things.
That's cool. It's definitely an interesting project and creates some very neat artwork. That's neat. So as you've mentioned, you're an educator, and I'm curious for the folks listening. A lot of them are getting into electronics and programming. And if they were interested in this type of stuff, and I mean, you see students who are getting into all types of interesting things.
Oh
Um,
yeah, wow. Yeah,
any recommendations for somebody just getting into this kind of field?
come to RIT and have a tour.
Okay.
We're we're located in some of the worst weather in any city in the United States, probably, which means a good thing. The winters come and we stay inside and get stuff done. So there's so many things going on. It's really quite remarkable. We have students doing programming of drones for doing like crop analysis and multispectral stuff. That means like having 3 or 4 different cameras that are photographing, and those images are put together to see where the crops are growing well and where the crops might need to be, treated with insecticides and stuff like that. So that's like there's going to be huge amounts of jobs related to the drones. Doing measurements with drones, not just taking drones out and taking pictures of people at the beach or something like that, but actually using drones for, getting work done or, taking measurements. So that's a big deal. And we also have a lot of students that are very specialized in doing color analysis, where they can figure out the color of a print and reproduce it on a piece of paper to have it exactly the same color. And this is important for throughout all the web and advertising and film and the whole rest of that color stuff. And it's kind of, some of the times the students come and they'll go like, oh, look at this, piece of crap iPhone. Look at the oversaturation of red. And that comes into what people like. People like red images, images with the red saturated. So it's kind of funny that Apple takes that into consideration on their cell phones, as most cell phone developers do. They change the color calibration of their screens so that people think their screens look better. But we train students in all sorts of stuff. We also have a department here that trains students in ophthalmic photography, which is photographic for the eye, which is a medical profession. And if anybody out there wants a job, that's a place to get a job. We have about, I believe it's 100% employment rate in that program. We graduate about maybe a dozen students a year in that program.
Oh, wow, that's really neat.
Yeah, good paying jobs and in the medical field, and they go through certification processes. And so we kind of cover all sorts of stuff. And we do a couple programs that teach microscopy. And I also teach a class in scanning electron microscopy, which is a whole nother story.
So In your experience, what do you think are some of the challenges that people who are just getting into like high-speed photography would experience most?
The challenges, I think it's important for people starting out in high-speed photography to get a little bit of, a little bit of positive feedback, so they're able to get, a couple amazing shots, and they figure that it's something that is not, incredibly difficult to do, but it is something that does take, time. It takes time to build the apparatus. It takes time to come up with an idea that hasn't been done before. And sometimes it takes time just to set up an automated an automated project that sits there for a month, taking, thousands and thousands of pictures, and you get just that one, which is just perfect, and you quickly throw out all the rest, and you feel like, oh, it was easy. But like the water drip photography, you can without too much trouble, you can program that thing to just run and take 15, 20,000 pictures. You can run it tethered on your computer, and it'll fill up the whole hard drive. And then you got to look through all those computers and see all those images and figure out which image is the best. And that can, what kind of criteria are you going to use for the best image and things like that. But you can certainly take a lot of pictures pretty quickly. How to get started? I would say, use a very simple triggering system, like one of the Arduinos, and hook it up to like a laser or something like that, where you can capture an event at just the right time, and then just use your imagination. And these days, it's like, yes, we've shot a lot of fruit with bullets, but and it's safe, and safety is a big thing, because we work very closely with campus safety about the use of a rifle in the lab, and as students really look forward to that kind of project. But the bottom line is it's pretty cool to do some ballistic photography, but it's hard to come up with an idea of something you can photograph safely and shoot it with a bullet, because that's a difficult thing. Pretty much every soft object has been shot by a bullet with high-speed photography, and there's not too much left. But the students, they still do come up with ideas that are kind of fun.
So are you working on any projects currently that you'd be interested in telling us about?
I have dozens of projects. At any given time, there's too many projects. I do a lot of scanning electron work. So right now I'm building a cryo stage, which cools down specimens to liquid nitrogen temperatures. I'm doing some work with that. I'm setting every year I take pictures of fireflies. So I'm building in fact, I've already built it, and I should write it up for Make magazine, but is a little firefly attractor, which attracts a couple different species of fireflies in the Northeast here. It's different in each part of the country. They have their own species of firefly. And I program it to one species, and they'll come in and try to mate with the LED. But what's more interesting is that it attracts another species, which I did not purposely call. And I believe that second species is eating the first species. So, you run into some weird stuff like that may or may not be documented. And I don't know if that's really the situation or not, or maybe it's just a really big confused firefly of the wrong species. I don't know. But things like, cross laser beams. And I'd like to build a system which captures fireflies in flight by going through a cross laser beam, which is really a pretty easy project to build. But you once both laser beams are crossed, then you have the circuit turn off the laser beams, and then trigger a camera with the right delay and a flash that's triggered remotely. So all these different triggers can be programmed in pretty easily, and make a system like that work, which in the old days would have been fantastically complicated.
That is so cool. And with the lasers, just out of curiosity, are there like laser modules that work with Arduino?
Yeah, they're like $2 or $3, and they're little tiny visible red lasers. And we've been hooking them up to a tunable light source, a detector, light detector, which is the only ID that is on this light detector says flying fish. So we call it the flying fish light detector, which has almost no documentation on the web edit at all. I don't even know what company makes this thing, and it works fantastic. We can get this, everything to run beautifully. And I said, well, I should buy some more of these detectors. And this was just like 2 months ago. I had the students build a system to photograph fish in a fish tank. So this was part of their midterm exam. And they put a fish in there and had to photograph it automatically and everything, which was kind of a cool project. But I went to order a few more of these light detectors, and they don't make them clear anymore. They make them black for detecting infrared. So my lasers are visible, which I like to have visible lasers so that the students know where the laser is. And next year, I guess I'm going to have to remodify it to have the students have to build their own light detectors, which isn't a big deal. It's kind of fun to make your own light detectors. So there's a lot of stuff going on. One of my friends teaches physics, and he goes, yeah, if it doesn't have a laser on it, put a laser on it. Students like that better. So he teaches at Caltech, so I figure he knows what he's talking about.
Yeah, you can't really go wrong with a laser, I guess.
No, he's got 5 or 6 of these bright green lasers. We're not even allowed to have the bright green lasers on campus because they're too bright. But Caltech, I guess, plays by different rules. I don't think their campus safety knows about all those green lasers. So,
well, Ted, thanks so much for taking time to talk today. I really appreciate it.
Yeah, thank you for taking the time to talk to me, and let me know if I can help out on any of your projects.
Yeah,
sounds
absolutely.
like you got some fun things going on too.
Yeah, we do, and a lot. Just it's fun to see all the projects that people are working on. I think that's the most exciting part, is to see what people are up to.
Are you going to be at the Make Fair in San Francisco?
I don't believe I'm going to be there this, what is it, May 20th?
May 20th, yeah. My youngest son is in 8th grade, and it's the only year that he can go because all the other years they'll have tests, end-of-year tests. So I'm going to throw him on an airplane and go see the Make Fair and see what's going on. I'm told that there's a rumor that Adam Savage will be introducing people at the gate early in the morning on Saturday morning, but it may just be a rumor.
Huh, that's really cool. That's neat.
So sometimes he does that. He's a pretty good guy. So.
Yeah, that's what I've heard. That's neat. Yeah, I'm sure it's a blast. I have not been to that one yet. I've been to the New York one. I've enjoyed that. That's a great one. So.
Yeah, I haven't been to the New York one just because it's kind of difficult to get in and out of New York City, but I should go. I'm just so, if you're going to go to one, you got to go to the San Francisco one.
Yeah.
Just because it's, you stand in line there and there's 40 guys around you waiting to get a ticket, and I'm like, hey, what do you do for a living? And they're all, everyone in the line was an engineer, a PhD, a master's of, electrical engineering or something. And they're driving their little R2D2s that are radio controlled around in circles as they wait, So it was really quite something.
That's cool.
I've been a couple times, and it's on a different level than most of the other Make Fairs. So I would recommend going. But a good buddy of mine runs the Pinball Museum in Alameda and invites me out to talk pinballs and electronics and stuff like that. So we always have a blast out there.
That's cool. Great. Well, hey, thanks again, Ted. I appreciate it.
Yep, thank you. Thanks for taking the time.
Well, I hope you enjoyed the show. We'll make sure to link to a bunch of the stuff we talked about in the show notes. So if you're curious about what these coffee photos look like, these coffee drip photos, trust me, if you go and check it out, you won't be disappointed. It's really sweet. But thanks a ton for listening. I sincerely appreciate it. If you haven't yet, you can subscribe to our show on iTunes or whatever podcast feed you use. And also, if you could take time to rate and review the show on iTunes, it would be much appreciated. Well, I hope that the rest of your day, night, run, walk the dog, whatever you're doing, I hope whatever it is fantastic. And I, again, appreciate the time you're taking to listen. Have a great one. Bye.
This show is produced by Programming Electronics Academy, an online technology education company. We exist to help you create the technology you want in your life. If you are interested in learning more about Arduino, we welcome you to sign up for our free Arduino Crash Course, a 12-part video series with accompanying written lessons designed to teach the basics of programming Arduino. To register for the course, simply text your email address to 440-701-5311, or you can visit programmingelectronics.com and sign up there.